to find out the time period of oscillation. So we'll try to develop the different approaches here possible. Okay, friction sufficient for pure rolling. Okay, let me display this. And I'll release it. Okay, yes, spring force, Kx will act. The friction, uh, how the torque, I'm going to release from rest. Circle. Okay, now the friction will be in this direction. Okay, what about the acceleration? So acceleration of center of mass, there'll be torque about center of mass. So Kx minus. So let's try that one. So we know a lot of rolling motion ideas. Let me start with this one. So Kx. Okay, fine. So here, the moment I release it, so the spring force will act through the center of mass. That Kx will be, and if a force acts such that it passes through center of mass, how the rolling friction? We know that rolling friction should act backward. So this friction now will set up a torque for pure rolling. So this will be IC into alpha C. Then for pure rolling, no slipping. The friction is sufficient for pure rolling. Okay, like this, what happened? We'll get solving this. Okay, let's, what is our question? We have to calculate the acceleration. We have to show that acceleration proportional to negative of displacement. So therefore now, let me replace further. F equal to, this will be IC. This will be F into R, IC, AC, alpha C. No, it is AC by R. So therefore, what is F is equal to? ICAC by R square. Let me generalize. Later on, I'll come to the moment of inertia of different rigid bodies. Let's substitute. This equation I'm going to substitute in this one. So then it will become Kx minus ICAC R square equal to MAC. Look at now. So acceleration KR square X by IC plus MR square. So this acceleration, how it is, the displacement was given towards right. And the spring force is acting towards left. Okay, if you want negative sign, again we'll get confused. So I'm trying to avoid here. So comparing this with, so we will get time period. The time period depends on what all? Depends on moment of inertia. If the rigid body, if the ring, how much IC will be? MR square. If the disk, MR square by 2 is a solid sphere, 2 by 5 MR square. So ring, disk, solid sphere, hollow sphere. I think these are the four bodies, or better we can make it only four bodies here. Ring or hollow cylinder, both are same. Disk or solid cylinder, both are same. Hollow sphere, solid sphere. So four objects are there. All four objects, they're having same mass, same radius. Then, but moment of inertia will be different. So open to time period will be different. I think in the matchings, you may get questions of like this. They'll say rigid body. So they'll give the name. All the rigid bodies are having same mass and radius r. Then they'll ask you what about the time period. General discussions of like this can also be there for you in advanced exams, especially in matchings. They'll try to ask it here. Okay, like this, we are in a position now. We got time period. Okay, let's study the motion. What is the role of friction? This is something very important. I just picked up this problem to learn more about the rolling friction here. Okay, now what will happen after some time? It will be like this. This will be alpha, this will be acceleration AC. The friction will be acting here. Now, when it comes to mean position, what is the state of it? Let me make it small diagrams. Now, here it will have maximum velocity. So what about the friction here? Friction will be zero when it is at mean position because net force should be zero and spring is relaxed. Next, after this, what will happen? It will be so how the spring force? The spring force will be acting in this direction. How the friction should act? The friction should act in this direction. Then it will undergo retardation. It will have angular velocity. Velocity of center of mass will be like this. But the retardation will be like this. And finally, what will happen? It will again come to instantaneous rest. This will be the left extreme. Then spring force here will be maximum, Ka. Let me write, this is Ka. This is Kx is what I derived it. So let it have angular velocity, velocity of center of mass also. Okay, able to understand? So this will be the amplitude A. Again, when it returns back, I think a student has to study at least one oscillation, what actually happens and what is the role of friction is what needed. So here it will have Vm. Okay, fine. So this is what the friction. So how the direction of friction will be acting? On the right hand side here from the mean to extreme. So when the rigid body moves from complete one oscillation, I'll show it. When the rigid body moves from right extreme to mean, the friction will act backward. When the rigid body moves from mean to left extreme, the friction will act towards left. Again, from left extreme to mean, the friction will be acting towards left only. So the direction of friction, rolling friction, which is acting, will not be constant, will be varying harmonically here also. Sir, how you can see? I think it's very simple, no? Look at acceleration. It is proportional to displacement. Suppose shall we define this as t equal to 0, this condition? Then what is the equation of SHM will be? A cos omega t. Okay, now look at this, x equal to A cos omega t. So the for acceleration of center of mass will vary. This friction is directly proportional to acceleration of center. So friction will also vary harmonically. This is the very important. This is what I wanted to stress in this particular numerical. We got time period. What about the friction? The role of friction, the friction varies, the rolling friction varies harmonically with the time. So then can we plot equation for, So let's write equation for the friction. So this will be F equal to IC R square. What is AC? AC will be I have to bring that negative sign. So this will be the, so finally F is equal to, this will be IC. Okay, the friction will be proportional to negative of displacement. Okay, now we'll plot. We'll plot just all different types of graphs. We'll see what information we'll get it.